Close your eyes and picture a single traveler gliding in from deep space. It is not from our neighborhood. It is not bound to our Sunday. It will swing through once and never return. Astronomers call it Three-Eye Atlas, only the third confirmed interstellar object ever seen, a rare messenger from another star. Tonight, we slow down, breathe, and follow its one-way journey. Most comets loop around the Sun on long, closed paths. Three-Eye Atlas does not. Its path is open, a steep hyperbolic curve that never closes, which tells us it came from outside the solar system and will leave again. That is why the letter I is in its name. It stands for interstellar. The 3 marks it as number 3, after one I, Oumuamua in 2017, and 2 I Borisov in 2019. Atlas honors the survey that first spotted it in Chile. The discovery came on July 1st, 2025. A NASA-funded Atlas telescope in Rio Hurtado, Chile, noticed a faint point shifting slightly against the stars in Sagittarius, near the crowded heart of the Milky Way. Follow-up measurements showed the object was moving too fast to be held by the Sun's gravity. It had spent ages drifting between the stars before wandering into our skies. Within days, major observatories turned toward it. Hubble photographed the newcomer. The James Webb Space Telescope spread its light into a spectrum to read the gases around it, and as Three-Eye Atlas passes near Mars in October, orbiters there will also watch from a front-row seat. How big is it? We do not have a single exact number because the solid core is buried inside the glow. From Hubble's sharp data, astronomers estimate the nucleus is somewhere between roughly 400 meters and 5 or 6 kilometers across small by planetary standards, but enormous on a human scale. What matters most is not the size alone, but how the sun's warmth changes the surface as it approaches. As the traveler nears the sun, sunlight wakes it up. Ices in the crust turn straight into gas, lifting dust and forming a soft, glowing atmosphere called a coma. The solar wind pushes that material into a tail. On August 27, the Gemini South Telescope in Chile captured the first clear signs of that tail beginning to grow. A faint streamer blown away from the nucleus by sunlight and charged particles. Through September and October, activity rises, the coma swells, and the tail sharpens. Seen up close, the activity would look like a slow breath curling away into space, steady and calm. Now, place it on the calendar. Late October 2025 is the point of maximum heat. Around October 29 to 30, Three-Eye Atlas reaches its closest approach to the Sun, about 1.4 astronomical units away just inside the orbit of Mars, still far from Earth. For a few days, our view from home is blocked because the comet is hidden behind the Sunday. Then, in early December, it reappears in the morning sky, distant and safe, perfect for more study before it fades back into the dark. The closest it gets to Earth is about 1.8 astronomical units, roughly 170 million miles, so it remains comfortably distant. What is it made of? Webb's first look found a halo rich in carbon dioxide, along with water, water ice, carbon monoxide, and a few other simple molecules. That mix matters. High carbon dioxide compared to water suggests it may have formed in an extremely cold zone around its original star, far beyond where Earth-like planets grow. In short, when we study Three-Eye Atlas, we are holding a page from someone else's planetary cookbook. How fast is it moving? Very fast, even by space standards. At discovery, it was racing at roughly 137,000 miles per hour relative to the Sunday. That speed is the reason for the open hyperbolic path. Gravity will bend it, but not catch it. It will dive in, swing around, and head back out toward the constellations, carrying dust we can sample with light but never touch. Is it a comet, or something exotic like Oumuamua seemed to be? Unlike Oumuamua, which never showed a clear tail, Three-Eye Atlas behaves like a textbook comet waking up. We can see the coma. We can see a growing tail. We can measure water and carbon-bearing gases in the cloud around it. That makes it more like 2 I Borisov the icy visitor from 2019, than the slab-like mystery of 2017. Still, it is not boring. Early spectra show unusual ratios of gases, and that balance may shift as the surface warms and fresh ice is exposed. Why does it matter? For decades we wondered what small bodies from other stars might look like. Then, in a single decade, 3 of them wandered into view. Each is a messenger. Oumuamua whispered that shape and physics can surprise us. Borisov showed us a classic comet built somewhere else. And now 3I Atlas brings a larger, brighter sample with an active coma and a chemical recipe we can measure in detail. Together, they sketch a larger story: how common comets are in other systems, how they form, and how our sun stirs them when they wander through. So, as you listen, imagine the scene. Far below, our planet spins, cities dim, and oceans quiet. Out beyond Mars, a dark shard of ice and dust exhales in the sunlight, writes a thin line across the black, and keeps going. We have only a short window to learn from it. We will not chase it with a spacecraft this time, but we will use every telescope we have. We will gather spectra, images, and light curves. We will compare, argue, and refine what we know. And when it is gone, this quiet visitor will have left us better questions and clearer clues about worlds beyond our own. The night it appeared, it was only a moving dot. Against the crowded glow near the Milky Way's center, a faint speck slid a little between images while the background stars stayed still. Software raised a gentle flag. Humans checked. The numbers agreed. This object was moving too fast, on too open a track, to belong to our Sunday. That is how 3I Atlas entered the story, a traveler from the dark between the stars. Let's decode the name in simple terms. The 3 means this is only the 3rd interstellar visitor ever confirmed, after Oumuamua in 2017 and Borisov in 2019. The I stands for interstellar. Atlas honors the survey that found it, using a NASA-funded telescope in Rio Hurtado, Chile, on July 1st, 2025. The discovery was not a single dramatic photo. It was a short time-lapse where the same dot shifted a tiny bit from frame to frame. That slide told astronomers they had something special. How do we know it truly came from outside the solar system? Imagine gravity as a patient hand. If a traveler is slow, that hand curls the path into a loop, and the traveler returns. Most comets follow long ovals like that. 3I Atlas does not. Plot its motion and you get an open curve, a swooping V that never closes. In orbital language, it is hyperbolic, which means unbound. The sun will bend the path, but cannot keep the visitor. It will dive in, turn the corner, and leave forever. Once the alert went out, telescopes around the world and in space lined up. Hubble stared and revealed a soft, teardrop glow cocooning a hidden, solid heart. That glow is the coma, a thin atmosphere of gas and dust that switches on when sunlight warms buried ice. From those images, scientists narrowed the size of the nucleus. It is not a pebble, and not a city. Think somewhere between a few hundred meters and a few kilometers across. A rugged, irregular block spinning slowly as it exhales. While Hubble worked on size, the James Webb Space Telescope listened for chemistry. Webb spreads light into a rainbow and reads the fingerprints of molecules. In early August 2025, Webb found that the gas around 3IA ATLAS is unusually rich in carbon dioxide compared with water. In most comets we study, water drives the activity near the Sunday. Here, carbon dioxide plays a bigger role than usual. That single clue points to a cold birth zone around another star far beyond where rocky planets like Earth tend to form. You may have seen loud headlines claiming the object could be artificial or dangerous. Sensational ideas make easy clicks. The measurements tell a calmer story. We see the coma. We see a tail growing as sunlight pushes dust away. We detect ordinary comet gases, water, carbon dioxide, carbon monoxide, and a few sulfur-bearing molecules glowing in infrared light. NASA scientists and mission teams have said clearly that 3I Atlas behaves like a natural comet and poses no threat to Earth. There is, however, a remarkable observing chance on the way, not from Earth, but from Mars. In early October 2025, the comet passes near Mars on its inbound leg. European orbiters at the Red Planet plan to watch, turning their instruments toward the visitor as it glides by tens of millions of kilometers away. Imagine observing an interstellar comet not from a backyard, but from another world. Those vantage points could show how the coma changes in real time as fresh ice layers wake up. Where is the traveler now in its seasonal arc? Through September, it brightens slowly as sunlight digs deeper and more gas drifts off the surface. Late October brings perihelion, the moment of maximum heat when the comet is closest to the Sunday from Earth. That timing is inconvenient because 3I Atlas sits too near the sun on our sky to observe safely. The pause is brief. In the first days of November and into early December, geometry shifts and the comet emerges from behind the sun into the morning sky. The closest it gets to Earth comes in mid-December, at about 170 million miles away, distant and safe for everyone watching from home. A small but beautiful coincidence makes this passage even more useful. Interstellar objects do not share our planetary traffic lanes, yet by chance, 3I Atlas slices almost along the flat plane where the planets travel. That alignment pulls it past several worlds, Mars first, then a more distant pass by Venus weeks later, and months after that a safe, far-out meeting with Jupiter on the way out. It never comes near Earth. But that sequence gives our spacecraft and large telescopes multiple windows to study the visitor from several angles as it hurries through the inner solar system. If you could ride alongside it, the view would be modest and hypnotic. The nucleus would be dark and rough, a lumpy iceberg mixed with dust, black as charcoal in places. On the sunlit side, jets would whisper into space like slow steam from a kettle. The tail would not flap like a flag. It would drift like a river of tiny grains and gas, steadily pushed away by sunlight and the solar wind. Up close, it would be silent. Only when we translate that light into data do we hear the story it carries. Step back now and breathe. Why tell this tale in a calm, simple voice? Because 3I Atlas is a reminder of scale and time. Our lives move quickly. Headlines flare and fade in hours. This traveler has drifted in darkness for eons. For a few quiet months, it glows and lets us learn. Then it slips back into the night between the stars, leaving us with better questions and a little more patience for the slow work of the cosmos. Imagine a quiet hill before dawn. The sky is dark blue, far beyond Mars. Sunlight touches a small traveler and turns into a pale mist. From Earth, we see a soft glow, not sharp edges. That glow is our evidence. With light alone, astronomers learn where the visitor came from, how it moves, what it is made of, and even how it spins. Start with motion. Take 3 pictures a few minutes apart. If the dot shifts while the background stars stay fixed, you can measure its path. Feed those positions into software, and you get a first sketch of the orbit. At the beginning, that sketch is wobbly, like a pencil line drawn on a moving train. Each new measurement tightens it. Over nights and weeks, the uncertainty shrinks, and the path settles into a clear shape. For 3I Atlas, that shape never closes. It stays open, the signature of a hyperbolic, unbound path. There is a simple way to picture the speed. Far from the sun, where gravity's pull is weak, 3I Atlas has a steady cruising pace. Specialists call it the hyperbolic excess speed, the part of the motion the sun cannot remove. As the object falls inward, gravity loans it extra speed. After it rounds the sun and climbs back out, it pays that loan back and returns to its cruising pace. That is why it cannot be captured. Brightness is the next clue. The solid heart is small and dark, but the coma can be larger than a planet. Sunlight warms the surface. Ice turns straight into gas. Gas lifts dust. The cloud grows. By tracking how bright the glow becomes at different distances from the sun, Scientists estimate how active the surface is and infer a rough size for the hidden core. The idea is simple: more sunlight, more gas, more dust, more glow. If the glow jumps in a single night, that is an outburst. It can happen when a crust patch cracks or fresh ice is exposed. Look at the tail, and you can read the forces at work. One part of the tail is made of dust pushed gently by sunlight. Larger grains are heavier, so they lag and curve, drawing a broad ribbon behind the comet. Another part is made of ions, atoms that have lost electrons, and now feel the solar wind. This ion tail points almost straight away from the sun, like a windsock in a strong breeze. In photographs, ion tails often look bluish because of molecules that glow in that color. Dust tails tend to look warmer, yellow to white, as sunlight reflects from tiny grains. Even the flicker of the glow carries news. As the nucleus spins, active regions rotate into sunlight and then into shadow. That cycle makes the brightness rise and fall with a gentle rhythm. By measuring that rhythm, astronomers estimate the rotation period. Many comets turn every few hours, some take a day or more. If jets are uneven, they can act like tiny thrusters and nudge the path. These non-gravitational pushes are measured and folded into the orbit so predictions stay accurate. Chemistry is a third key. Each molecule is a note in the comet's song. Water means ordinary ice is present. Carbon monoxide and carbon dioxide point to colder birth zones, where even the most fragile ices can freeze. Methanol, ammonia, and sulfur-bearing species hint at the ingredients in the cloud that formed the comet's home star. Interstellar visitors give us rare comparison samples. They were shaped in other systems, under different kinds of light and heat, and then set adrift. When we find which gases dominate, we trace the temperature history of the place where it formed. You might wonder how a small object survives a trip between the stars. Space is mostly empty, but over millions of years, even emptiness can wear things down. The nucleus is probably a tough, icy aggregate with dust filling the cracks. Like a frozen gravel pile, it drifts cold, mostly asleep, until a new sun warms it. The first breath of gas can lift a veil of dust and hide the core again. From far away, we see only the glowing veil and the tail it sheds. What about danger? The calm answer is no. This traveler does not come anywhere near Earth. Its path carries it inside the orbit of Mars and then back out, staying many tens of millions of miles from us. That distance is a gift. It gives us time and safety to observe. It also lets many instruments take turns. Large telescopes on the ground, observatories in space, and for a short window, spacecraft around other planets. Think about the larger picture. In the last decade, we have watched 3 interstellar visitors. That alone is stunning. It means our surveys are now sharp enough to catch these rare passers-by. It also means our solar system is not isolated. Bits of other systems drift through ours, and, in return, we surely send our own fragments out to wander. The galaxy is not a sealed neighborhood. It is a slow exchange of small cold letters moving through deep time. There is one more quiet gift here. The word comet often brings panic and doom to mind. Instead, 3i Atlas invites patience. It shows that you can understand great distances with simple ideas. Watch the dot move. Watch the glow breathe. Watch the tail point away from the Sunday. From those signs, a story appears. You do not need heavy equations to feel the elegance. The universe teaches in plain light, and tonight, that is enough. Close your eyes again and picture the traveler turning the corner around the Sunday. The tail sweeps like a slow fountain. The coma dims as the heat fades. The cruising speed returns. The dark between stars opens ahead. Our instruments fall behind. Our questions move forward. The message has been delivered, and the messenger goes on. If you have heard of the first 2 visitors, you already know the melody. Oumuamua in 2017 was a surprise, with no clear tail and a strange push that sparked years of debate. Borisov in 2019 was a classic comet, small, fast, and unmistakably icy. 3i Atlas carries notes from both. Like Borisov, It breathes out gas and dust in sunlight. Like Oumuamua, it brings fresh puzzles in its chemistry and timing. Together, these three are not a crowd, but they are enough to show a pattern. Other star systems make small bodies too, and sometimes those bodies wander. What makes 3I Atlas stand out is the clarity of the show. From early on, its coma and tail were visible. That matters because a visible coma turns light into a readable book. We can track how activity rises as it warms, how the tail shifts direction with the solar wind, and how the brightness flickers as the nucleus spins. A calm, steady increase is a sign of a stable surface. Sudden jumps hint at vents opening or crust cracking. Each change is like a soft knock from beneath the ice, telling us the visitor is waking layer by layer. The calendar places our story near October's end. Around that week, the object is closest to the sun and the heat is strongest. For observers on Earth, that is a mixed blessing. The visitor is most active, yet it is too close to the sun's glare to watch safely with ordinary telescopes. The sky will clear again in the weeks that follow. Then the glow returns to the morning, and the measurements resume. Science sometimes feels like fishing. You cast, you wait, you reel in what you can, and you accept the quiet gaps the sky gives you. You may wonder why we cannot just send a probe to meet it. The honest answer is timing. Interstellar objects move fast and appear with little warning. Spacecraft take years to plan, build, test, and launch. By the time we spot a traveler like this, it is already rushing past. A new idea is growing to solve that problem. Imagine keeping a small spacecraft ready and waiting far from Earth, like a sprinter on the starting blocks. When the next visitor is found, the sprinter launches toward it. That is the dream behind interceptor missions. They will not catch 3I Atlas, but one day they may greet a future guest face to face. Until then, light is our messenger, and chemistry is our dictionary. When we say this comet is rich in carbon dioxide compared with water, we are really saying it likely formed in a colder part of its original system. Think of a kitchen. Water freezes in a normal freezer. Carbon dioxide needs the deep freeze. If a comet releases a lot of carbon dioxide even before it gets very warm, it probably carries layers that spent ages in that deep cold. That simple picture helps us compare how other planetary systems build their small worlds. Another common question is whether dust from 3I Atlas could give us a meteor shower. The restful answer is no. The path does not cross Earth's orbit, and the dust will spread along the comet's own track like a thin, distant ribbon. Our skies will remain unchanged. The only showers here will be showers of data spectra, images, and careful brightness curves, quiet numbers stored in archives, ready to be compared with the next interstellar traveler. There is always a chance of drama. Some comets crack or split as they warm, others shed large pieces that drift away like slow-moving boulders. With 3I Atlas, the risk is lower because it never dives close to the sun, but outbursts can still happen. If the crust breaks over a pocket of fresh ice, the coma can puff brighter in a night. For scientists, these moments are gifts. A burst sweeps dust from inside the nucleus into the light, letting us sample older material that has been hidden for eons. How do we keep the measurements honest? By listening to many instruments at once. Big mirrors on the ground take sharp pictures. Space telescopes read the faint fingerprints of molecules in infrared light. Small, nimble observatories collect long time series to measure the rotation rhythm. Even spacecraft around other planets can help if geometry puts them in a good spot. When several eyes agree, confidence grows. When they disagree, we learn where to look closer. In astronomy, conflict is not a fight, it is a map to better answers. The larger meaning sits quietly behind the facts. 3 interstellar objects in less than a decade tells us our surveys have entered a new era. Wide-field cameras sweep the sky every night, and software now notices the tiny shifts a human might miss. Soon, even deeper surveys will begin, and the count should rise. With each new object, we will refine a census. How many icy visitors are out there, how bright they get, how their chemistry varies, and how often they surprise us. Somewhere in that growing sample may be a fragment from a system not much older than ours, or much younger, or lit by a different kind of star. If the first two visitors taught us anything, it is to stay humble. Oumuamua said tales are not guaranteed, and shapes can be strange. Borisov said, familiar physics still rules in other homes. 3i Atlas says patience pays off. A clear coma, a safe distance, and a long window give us room to breathe and learn. None of these travelers stayed, none left a souvenir we could hold, yet each left a trace in our understanding, like a soft footprint in snow that points the way forward. So let us keep the tone gentle. Picture the object beyond Mars, a dark seed wrapped in its own breath. The tail points away from the sun, like a slow stream. Day by day, the light fades, like embers cooling in a fireplace. The speed never really changes, only the warmth does. As the traveler coasts back into interstellar night, the questions it raises remain with us. How common are these guests? What patterns will appear when we have seen 10 of them, or 50? And will we be ready next time to meet one up close? For now, this is enough. A quiet dot, a moving path, a chemistry lesson written in light, a reminder that our solar system is part of a wider conversation, spoken slowly across the galaxy. The messenger passes on. We keep listening. Think of this visitor as a weather report written in starlight. Every wavelength tells part of the forecast. In visible light, we see the broad Coma and 2 classic tails, a soft dust stream that curves behind, and a thinner ion tail that points almost straight away from the Sunday. Infrared light reveals the warmth of tiny grains, glowing like coals as they cool. Ultraviolet light highlights fragments of water, leaving a faint signature that says, very simply, the ice is awake. Each instrument adds a clean page to the notebook. Large telescopes map the Coma's shape and watch how it expands. Fast cameras look for outbursts, those brief surges when a crust patch cracks and fresh ice begins to breathe. Spectrographs turn light into rainbows so scientists can identify gases. Polarimeters read how light scatters from dust to estimate grain size and surface roughness. Even radar may try, though the echo would be faint. Together, these pages form a calm mosaic rather than a single dramatic shot. If you want to look for the traveler yourself, the rules are kind. Go somewhere dark, let your eyes adapt for 15 minutes. Start with binoculars, not a high-power telescope. Comets are spread out, and a wide field is often the most honest view. Expect a cloud, not a special effects movie. If you photograph it, use a tripod or a small star tracker. Take a handful of short exposures and stack them later. The picture you make is a sketch with light, a quiet proof that you shared the sky with a visitor. The tails carry slow, readable physics. Dust grains of different sizes feel sunlight pressure differently. Small grains are pushed hardest and drift into wide fans. Larger grains trail closer to the path. That is why the dust tail arcs like a brushstroke. The ion tail is stricter. The solar wind, charged particles streaming from the sun, grabs ionized gas and pulls it almost straight back. When a solar storm sweeps by, the ion tail can snap and reconnect. A brief disconnection event that looks like a ribbon of light drifting down the tail. Spin adds another layer of rhythm. Picture sunlight moving across a rugged surface with a few vents. As the nucleus turns, each vent faces the sun, breathes for a while, then rests in shadow. From Earth, that rotation appears as a gentle heartbeat in the brightness. Measure the pulse for days, and you can estimate the rotation period. If the jets are uneven, they act like tiny thrusters and nudge the path. Astronomers model those small pushes so the orbit stays true. Chemistry changes with the season. Early on, fragile ices such as carbon monoxide and carbon dioxide wake first because they evaporate in weak sunlight. Later, as the surface warms, water takes the lead and the balance in the coma shifts. Think of layers in a cake, each chilled in a deeper freezer. As heat opens those layers, we read the temperatures that shaped them, clues to the comet's birthplace around another star. The exact ratios matter to specialists, For the rest of us, the message is simply born in deep cold. Because the comet remains far from Earth, our planet does not shape its behavior, the sun does. As the solar wind flows past the Coma, magnetic fields drape over it and create an invisible tail. Where that flow meets the comet's thin atmosphere, a soft bow shock forms, like ripples ahead of a slow boat. Spacecraft have flown through structures like these at other comets and felt the change directly. For this visitor, we infer the shapes from the way the ion tail reacts to the sun's shifting mood. Public excitement can pull rumors into the conversation, so let's keep the air clear. A visible tail does not mean danger. A high speed does not hint at a collision. Interstellar simply means unbound. This traveler stays far from Earth, which is a quiet blessing. It gives observers time to plan, to compare notes, and to watch the Coma's slow weather without fear. The best response is patience. Measure gently, and let the light tell the story. There is peace in the craft of observing. Picture a dome opening before dawn. The air is cold and steady. A red flashlight glows on a notebook. The telescope hums as it tracks. An exposure ends, and on the screen a soft comma appears, brighter at one edge, where the nucleus hides, a faint tail stretching away. Another exposure, a little deeper, reveals thin streamers within the glow. You note the time and the filter. You breathe. Attention turns into kindness, and the comet answers with detail. As you drift towards sleep, keep this feeling, a distant traveler, steady and harmless, sunlight turning ice into breath, dust flowing into a slow river, instruments reading simple clues and turning them into understanding. No crashes, no countdowns. Only the long, quiet conversation between a small, dark object and a warm star, witnessed for a season and then left to the night again. When the glow fades, the data remains. Images rest in archives. Spectra line up like pages in a book. Light curves rise and fall like tides. Years from now, students will pull those files, compare them to the next interstellar visitor, and see patterns we cannot see yet. That is the gift of a careful campaign. It outlives the headlines and feeds the next questions. The sky teaches slowly. We are learning to listen at its pace. Picture how a traveler like this is born. Around a young star, there is a thin, dusty disk of gas and ice. It looks calm, but inside the disk, patches clump, collide, and stick. Pebbles become boulders. Boulders become mountain-sized bodies we call planetesimals. Most of them settle into families, the seeds of comets, asteroids, and future planets. But some are destined to be flung away. Giant planets act like pinball bumpers. A close pass steals or adds speed, and the small body is shot outward. After a few kicks, it clears the system entirely and drifts into the galaxy. That is one likely origin story for an interstellar comet, like 3I-80LAS, a leftover seed born in another star's nursery, launched into deep night by a gravitational shove. There are other paths to exile. In the crowded neighborhoods where stars are born, near misses are common. A passing star can tug on a young system and unhook a distant comet with a single pull. Over millions of years, those gentle thefts add up. What leaves one system becomes the background population for the next. In time, space fills with quiet wanderers, small, dark, icy objects, between the stars most too faint to see, a few lucky ones drifting into our searchlights. If you picture our own backyard, you can see why this makes sense. Far beyond the planets, our sun likely keeps a deep reservoir of comets in a vast sphere called the Oort cloud. Think of it as the slow outer rain of leftovers from planet building. Every so often, gravity nudges one inward. Most loop around the sun and go home. A few are lost to interstellar space. We assume other stars keep their own cold reservoirs and lose a trickle too. The galaxy, then, is not a sealed apartment. It's a building with open balconies, and small things pass between them. What happens to a wanderer during the long cruise? Space weather leaves a mark. High-energy particles slowly darken the surface. Fragile ices hide under a thin crust. Dust settles into pores. Over eons, the skin becomes tough and dry. The first time a new sun warms it, the outer layers resist and then crack. Gas escapes through vents. Dust lifts. The coma switches on like a soft lamp. 3i Atlas seems to fit this rhythm, a sleeper stirring, then breathing steadily as sunlight finds the seams. Now widen the view and follow the chain of discovery that made these visitors visible. For most of history, comets arrived as sudden apparitions, found by patient eyes that swept the sky. In the last 2 decades, we have taught robots to do the sweeping. Wide-field cameras now patrol the whole dome of the night, taking fast, deep snapshots and comparing them automatically. The software does not get bored. It notices a dot that isn't where it should be and taps a human on the shoulder. That is how the first 2 interstellar visitors were found. That is how 3i Atlas was flagged. And that is how the next ones will appear quietly, in a stream of alerts, the rarest dots hidden among millions. Each alert begins a choreography. Observatories large and small share time. Some gather long sequences to time the spin. Some collect spectra to read the gases. Others take the sharpest images they can to measure the coma's shape and tail. Amateur astronomers add wide, steady light curves from backyards and mountain pullouts. No one instrument tells the whole story. The beauty is in the overlap, the way slow, careful measurements turn a faint blur into a textured portrait of a world we will never touch. What can that portrait reveal about its home? Chemistry carries the accent of the place where the comet formed. If a visitor exhales more carbon dioxide than water when it is still far from a star, that hints at a birthplace in extreme cold. If it wakes water only later, closer in, that tells us the layers are arranged like blankets in a freezer. Dust colors add clues too. Redder dust can mean long exposure to radiation. Polarized light can betray grain size, telling us how fragile or compact the surface. Island piece by gentle piece. A picture emerges of another solar system's climate, written in a single drifting shard. There is also meaning in the way the coma changes day by day. A steady, gradual rise in brightness suggests a surface that is uniform, no big surprises, just sunlight doing its work. Sudden bursts hint at doors opening to deeper ice. Sometimes a comet splits when internal stresses grow too high. Even a small fracture can send a puff of fresh dust into space, like tapping a cushion and seeing glitter drift. These small events are not failures. They are windows. They let us sample older material sheltered from space for ages. All of this might sound delicate, and it island, but the ideas are simple enough to hold as you drift towards sleep. Gravity bends paths. Sunlight warms ice. Gas carries dust. Dust makes a glow. The glow tells a story. Each interstellar visitor brings a new chapter. Oumuamua whispered that not every traveler will wear a classic tail. Borisov affirmed that many will. 3i Atlas shows what we can learn when a visitor stays bright, safe, and well-placed for months. With patience, we read the weather of a foreign birthplace in the calm breath of a comet. Imagine, then, the long return. The traveler climbs away from the Sunday. The glow thins, the tail stretches, fades, and finally vanishes. The nucleus cools back into silence. The hyperbolic curve carries it out of our planetary lanes and back into the big, dark ocean between stars. Nothing in our sky points to it anymore, but the record remains, a set of images, a stack of spectra, a rhythm of brightness in a file. From those quiet pages, our picture of the galaxy's small citizens grows clearer, and this is the quiet promise ahead. With each new survey, with each better camera, with each bit of software that learns to notice what we would miss, more visitors will enter the story. We may one day see one early enough and slow enough to meet it with a waiting spacecraft. Until then, light is enough. It is patient, gentle, and generous. It crosses the cold and carries the message. We only have to receive it and listen. Think for a moment about what it means to predict a comet's future in the sky. We read light and geometry. Picture a lamp and a dusty marble. As you move the marble around the lamp, the brightness changes with the angle you see it from. Astronomers call that The phase angle, the sun, the comet, and you forming a triangle. When the comet slips almost between us and the sun, sunlight can scatter forward through the dust and make the coma look brighter than expected. At other angles, the glow softens. That simple play of light helps explain why a comet can seem to wake suddenly and then calm again. Geometry also sets the clock for when we can look. A useful observation needs separation from the sun on the sky, called solar elongation. If the visitor hugs the sun, glare overwhelms it, and we pause. As the angle opens, the comet steps into darker sky, and details return. That is why the most energetic weeks of outgassing can be the least photographed. We wait out the glare, then pick up the thread as dawn or dusk gives us room. Even when the sky cooperates, a comet never shines like a planet. It is a cloud, and clouds spread light. Under a dark, moonless sky, small binoculars can be more honest than a big telescope because they gather the whole glow at once. The comet appears as a soft patch with a brighter seed at one edge, the hidden nucleus and its sunlit jets. This is not a special effects show. It is a sketch in light, delicate, and real. Brightness curves are our sheet music. Observers around the world log measurements night after night, and those points rise and fall like a melody. A smooth climb means steady warming. A sudden spike is an outburst, the moment when a crust crack opens a vent and fresh ice sighs into space. A plateau hints that dust has mantled the surface, smothering the jets until sunlight digs deeper. 3-eye atlas may show that full range, steady, then lively, then calm again. Dust itself tells stories. The finest grains are smoke-like and float far down the tail. Slightly larger grains drift into streamers that curl with the comet's motion. Pebble-sized clumps lag behind, leaving a dotted line a long exposure can reveal. The solar wind charged particles from the sun grabs ionized gas and pulls it almost straight back. If a solar storm sweeps by, the ion tail can snap and reform. A quiet weather front in space. There is an art to separating what is real from what is wishful. Our minds love patterns. We see arrows and faces in clouds. We imagine structure where there is only gentle noise. That is why teams blend many kinds of data and many points of view. Wide-field images show the large brushstrokes. High-resolution views reveal the inner coma. Spectra tell us which gases are present. Polarization maps hint at grain sizes and surfaces. When the pieces agree, confidence grows. When they disagree, the disagreement points to better answers. Interstellar comets add one more layer. They are postcards from other kitchens. The ingredients are familiar: water, carbon dioxide, carbon monoxide, a handful of simple organics, but the proportions vary. That balance is a clue to the freezer they were built in. How far from their young star, how quickly that star brightened, and what neighbors tugged at the disk. By comparing 3-eye atlas with Borisov and with future visitors, we are slowly building a cookbook for worlds we have never seen. You might ask whether such wanderers could ever seed life. The calm answer is that they can carry raw materials, not ready-made answers. Dust and ice from comets include simple organic molecules, the kind that can form in cold, dark places and survive gentle warming. That does not mean life rides along. It means the galaxy recycles building blocks. Planets, atmospheres, and oceans do the slow chemistry. Comets deliver some of the ingredients. On the human side, interstellar visitors are changing how we plan exploration. Engineers are sketching interceptor spacecraft that wait in deep space, fueled and tested, ready to sprint when an alert goes out. A craft like that would carry a small set of instruments, a wide camera for context, a high-resolution imager for jets and surface texture, and a compact spectrometer for gases. We do not have such a sprinter for this visitor, but each new object sharpens the design and strengthens the case for keeping one ready. For now, our best tool is rhythm. Every clear night adds a note. Every spectrum is a word. We stack them without hurry, and a paragraph appears. A year from now, the object will be gone to naked eyes and small telescopes. But that paragraph will remain in the archives, ready to be laid beside the next and the next. This is how a field matures through patient layers rather than sudden declarations. Hold a closing image in your mind. The traveler is past the sun now, coasting outward on its open path. The coma is thinner, like breath on a cold morning, fading to nothing. The tail is a ghost river following behind. The spin only seems to slow from our vantage. In space, it keeps its steady turn. No alarms, no threats, just the simplest physics doing its quiet work. When you step outside at dawn, the same sunlight that touched that distant ice warms your eyelids. The universe is enormous, but the light is shared. Picture the quiet system behind every dot of news. A survey camera sweeps the sky. Software spots a mover, and the alert pings around the planet in minutes. A team in Chile takes spectra before sunrise. A graduate student in Italy combines the positions and updates the path. By nightfall, the orbit tightens, and the visitor has a name. Names sound dry, but they are really labels on memories. The 3i says this is the third interstellar object we have seen. Atlas points back to the survey that first noticed it. Later, if another telescope refines the orbit or measures chemistry, those details join the same file. It is a living card in the catalog, updated each time a new eye looks. Years from now, a student can open that card and see the arc of discovery like footprints. What can the record tell us that a single picture cannot? Time. A still image shows a soft glow and a tail. A timeline shows how that glow grew, how the tail swung after a gust of solar wind, and how the rotation rhythm shifted as new vents woke. Comets are moodier than they look. Some stay steady, others hiccup. The value is in watching the changes with gentle patience. An easy way to imagine the physics is to think of sunlight as a stream of tiny taps. Each photon pushes a dust grain a little. The smaller the grain, the bigger the effect. Over hours and days, those nudges fan the dust into a curve. Gas behaves differently. The sun's charged wind sweeps it back in a straighter line and sometimes tears it loose, like a gust pulling a thin veil. When the sun is quiet, the ion tail is smooth. When the sun flares, the tail can kink, break, and reform downwind. You may hear observers use a simple brightness yardstick with a short name. It is not important to memorize it. The idea is this: if you measure how much sunlight the dust reflects within a small circle around the nucleus, you get a handy number to compare comets. Higher numbers mean more scattering dust, and usually more activity. That single knob helps teams notice outbursts and track how quickly the coma is growing or settling. Another quiet clue hides in color. Fresh dust tends to look slightly redder than sunlight because very small grains scatter blue light away. Over time, radiation darkens surfaces and deepens the red. If 3i Atlas exhales fresher dust from under an old skin, we may see that tint change gently as the weeks pass. What does a comet smell like? If smell could cross a vacuum, we cannot sniff it, but we can translate spectra into familiar scents just for fun. Trace sulfur would read as a faint, rotten egg note. Ammonia would add a sharp, cleaning fluid edge. Alcohols can be present in tiny amounts. To chemistry, not cocktails. Those molecules form naturally in cold space and ride the gas into the coma. They are safe at these distances. All we catch on Earth is their fingerprint in light. On the calendar, late October marks the object's warmest days. Then the curve bends outward, and a long cool-down begins. Picture the surface like a shallow beach at sunset. Waves the sunlight keep lapping for a while, even as the sky darkens. In comet terms, that means activity lingers. The coma does not switch off like a light. It breathes more softly, hour by hour, day by day. For weeks, the tail stretches and thins. By early winter, the glow is smaller, but still worth measuring. Why do predictions of brightness come with wide error bars? Because a thin crust can hide deeper ice. If a crack opens, fresh material escapes and the comet brightens faster than a smooth model would guess. If dust falls back and blankets the surface, jets can smother and the glow dim early. Both can happen on the same object. The models are good at guiding telescopes, not at telling fortunes. The sky gets the last word. The human side matters too. Many of the best light curves will come from people whose names you never hear. Retirees who love the night, students with borrowed time on a small scope, volunteers who write code to clean noisy measurements. They work quietly, share data freely, and trust the next pair of eyes to check their sums. Interstellar visitors also shift how we think about our own origins. If small, cold bodies drift between stars, then planet building is not a private hobby. It is a common craft across the galaxy. Bits are traded, recipes are tried in many kitchens. By tasting the dust and gas from 3i Atlas, we sip a hint of another world's weather. Not the whole climate, just a clean note that says born in deep cold, far from a young Sunday. Could an object like this ever settle here? In theory, yes, but only if it lost a lot of speed, usually by a close pass with a big planet. This traveler does not take that route. It stays far from the giant worlds and keeps its freedom. The sun bends its path but never closes it. There is a quiet beauty in that, a respectful visit, a graceful turn, and a long goodbye into the dark. Hold one last image for tonight. Imagine a quiet field before dawn. The air smells of frost. Above the eastern hills, the sky grows pale. Through binoculars, you find a soft thumbprint of light, with a thin tail pointing away from the hidden Sunday. It does not flash. It does not roar. It simply is. A guest from far away, writing in the simplest ink. You lower the glasses, breathe out, and feel a little larger inside your chest. Somewhere, far beyond what you can see, the traveler keeps going. Imagine viewing the same traveler from 3 balconies. From Earth, we see a delicate glow low in the sky, a soft comma of light. From space, an observatory looks down the dark, watching the ion tail stretch like a silk ribbon away from the Sunday. From another world, say, a probe orbiting Mars, the angle shifts again, and the comet's breath looks different, as if a breeze had changed direction. Nothing about the nucleus changed, only our vantage point did. That is one of the quiet lessons of astronomy. Perspective is a kind of instrument. Light itself adds a gentle delay to every scene. Sunlight leaves the sun, touches the dust, and scatters toward us. Those photons cross the void in minutes, carrying the story of whatever the comet was doing when the light left. It feels instant, but it is always a message from a few minutes ago. For a slow, steady comet, that delay is nothing. For a sudden outburst, it is a reminder that even now in space has a soft echo. Seasons exist on comets too, not spring and fall with flowers and leaves, but seasons of light. If the spin axis tilts, one hemisphere leans into sunlight and then away as the object travels. A vent that slept through a long, cold winter can wake when its patch tips into day. The coma brightens, the tail thickens, then months later, the same patch cools and rests. Seen from Earth, this looks like mood. Inside, it is just geometry and heat taking turns. The surface is not smooth. Think of a dark, dusty rind over layers of ice and grit. Sunlit slopes warm first. Shadows shield tiny cliffs. Jets whisper from cracks and pits. In high-resolution images of other comets, we have seen ledges, boulders, and sinkhole-like mouths where gas escapes. For a visitor from another star, we infer such shapes from behavior. A steady light curve suggests many small vents. A lopsided rhythm hints at a few strong ones rotating into view like lighthouse beams. Those jets do more than shine. They nudge. Each narrow stream is a tiny thruster. Over hours and days, the pushes average out. Over weeks, the path can shift by a hair's breadth compared to pure gravity. Astronomers measure that hair's breadth by fitting the orbit again and again. If the comet runs a little ahead or behind where gravity alone would put it, the models add a small, steady push to match the data. It is not drama, just honesty. Sunlight turns ice to gas, gas escapes, and Newton keeps the books. Solar weather writes on the tail. The solar wind is a breeze of charged particles that flows outward all the time, but it can gust. When a gust arrives, a wave from a solar storm, the ion tail can briefly break and reconnect farther downstream, a disconnection event. From night to night, photographs catch the change like a crease in silk. The dust tail ignores most of this, curving at its own slow pace, guided by sunlight pressure and the comet's motion. Color is a subtle clue. Fresh, fine dust tends to scatter blue light away and reflect a hint more red, so the coma often looks slightly warmer than starlight. Over long timescales, radiation darkens exposed surfaces, deepening that tint. If 3I Atlas exhales fresher material from beneath an old crust, the hue can shift gently week by week. Instruments notice what human eyes do not, and a careful color record becomes another way to map what layer is waking. Scale is the hardest thing to feel. The nucleus might be mountain-sized, but the coma can grow larger than a planet. Even so, everything is thinner than the best vacuum here on Earth. You could fly through the outer coma for hours without seeing a single grain as big as a speck of smoke. The glow is not density, it is sunlight scattered by countless tiny particles in a vast airy cloud. That is why the object looks soft in the eyepiece, and why binoculars often give the most honest view. People sometimes ask whether comets carry messages about life. They do, but the message is about ingredients, not recipes. In the coldest corners of space, simple molecules form on dusty grains. When a comet wakes, those molecules ride the gas into the coma. We read them as lines in a spectrum, signatures that say, water is present, carbon dioxide is strong, a hint of organics here. These are not promises, they are possibilities. Planets and time decide the rest. Another gentle truth: we will never know which star first lit this traveler. The path in is clear, the path out is clear. But wind back millions of years and the trail blurs among the motions of many stars and their gravity. What we can keep is the accent, the chemical balance that hints at a cold birth zone, and the temperament, the way the surface wakes and rests. From those, we learn about the kinds of places that make small worlds and the range of ways they behave when warmed. If you listen closely, a campaign like this sounds like a chorus. Big telescopes sing in deep notes, catching faint spectra and fine details. Small telescopes keep the tempo with steady light curves. Space observatories add pure, quiet tones above the atmosphere. Software blends the voices and lowers the noise. The melody is patience, the drum is time. The refrain is simple measurements, repeated gently. Hold an image near the end of the arc. The visitor has rounded the sun and begun its long climb back into night. The coma thins like breath on glass. The tail stretches, then frays. The spin keeps its private rhythm. Instruments fall quiet one by one as the glow drops below their thresholds. The final frames look almost empty until you stack them and the faint coma reappears, shy but still there. Someone logs the last point on the curve. Someone else closes a dome. The file is complete. We will see others. Our surveys grow faster and deeper every year, not because the sky changed, but because our attention did. The more we look, the more we notice. The more we notice, the calmer our questions become. Instead of, what is it? We ask, how does it breathe? And what does that balance of gases mean? And how does the tail respond when the sun sneezes? Those are quiet questions, but they build sturdy answers. Visitor by visitor, the galaxy becomes less abstract and more like a neighborhood with weather. For tonight, that is enough. A small, dark nucleus, a slow breath of ice, a curve that never closes, a guest that writes its name in light and leaves before dawn. You do not have to chase it. You only have to listen. Let's turn this visitor into a simple field guide you can carry in your mind. Page 1 is motion. Picture the sun as the quiet center of a pond. Drop a stone from far away and it does not circle. It slices in, bends near the middle, and slips back out. That is the shape of 3I Atlas, an open curve. The key number behind that shape is the leftover speed it keeps, even when it is very far from the sunday. Think of it as cruising speed. Gravity can speed the traveler up near the sun and slow it down again as it climbs away, but when the loan is paid back, the same cruising speed remains. That is why it cannot be captured. Page 2 is light. A comet is not a rock shining by itself. It is sunlight bouncing off dust and glowing gas. The solid core is wrapped in a thin atmosphere called a coma. Sunlight warms buried ices. They turn directly into gas, and that gas lifts dust into the glow. The tail is just the coma stretched out by sunlight and the solar wind. One tail is dust curved, soft, and slow. The other is ion straight, tight, and quick to react when the sun has a mood swing. Page 3 is rhythm. As the nucleus spins, vents rotate into day and then into shadow. From far away, that looks like a gentle pulse in brightness. If the surface is fairly even, the pulse is small and steady. If a few strong jets dominate, the light rises and falls more clearly, like a lighthouse beam turning. Sometimes a crust patch cracks, and the comet brightens in a single night. That is an outburst, the soft sound of fresh ice waking. Page 4 is color and texture. Fresh, fine dust tends to skew slightly red compared to starlight, because tiny grains scatter blue light away more easily. Over long exposure to radiation, surfaces darken and the red tint deepens. Instruments can measure that shift and tell whether the dust is mostly new or mostly old. They can also read how light is polarized, how it wiggles, and from that infer grain sizes and surface roughness. It is like touching a distant surface with the tip of a beam. Page 5 is chemistry, the ingredients label. Certain fingerprints in light mean water is present. Others mark carbon dioxide and carbon monoxide. A few lines hint at simple organics or sulfur-bearing gases. The exact balance is a thermometer for the past. If carbon dioxide rises early, before the comet is very warm, the object likely formed in deep cold around its original star. If water takes over later, nearer the sun, that says layers are stacked like blankets in a freezer, each waking at its proper temperature. Interstellar visitors let us compare freezers in other kitchens. Page 6 is weather, not our weather, the sun's. The solar wind is a stream of charged particles that blows outward all the time. When it gusts, the ion tail can kink or even snap and reconnect farther downwind. A brief disconnection event. Photographs catch those creases like folds in silk. The dust tail hardly cares. Sunlight pressure and the comet's motion guide its slow curve. Page 7 is safety and sense. High speed does not mean danger. Interstellar means unbound, not inbound. This traveler stays far from Earth. The best response is to watch without worry. That calm gives scientists time to plan, compare, and understand the slow changes in the coma without racing a clock. Page 8 is perspective. The same comet looks different from different balconies. From Earth, low in the morning sky, the glow may be soft and spread out. From a space observatory, the ion tail can look longer and straighter. From another planet's vantage, the angle of sunlight and the tilt of the spin can change which vents dominate. Nothing in the nucleus changed, only our line of sight did. Perspective, in astronomy, is an instrument all by itself. Page 9 is community. A survey camera posts an alert. Observers around the world pick up the thread as night rolls across time zones. Big mirrors gather exquisite spectra. Small telescopes stitch long, steady light curves. Software blends the notes, reduces the noise, and keeps the beat. The result is not a single spectacular image, but a careful duet of patience and detail. That is how a faint blur becomes a story. Page 10 is archives and memory. Every image, every spectrum, every timing point lands in a public file. Months later, when the glow has faded and the object is sliding back into the dark, the record remains. Students will compare those pages to the next visitor's pages and the next after that, looking for patterns, a typical balance of gases, a common range of spin rates, a usual curve for how brightness rises and falls with distance. With 3 visitors, we only glimpse the outline. With dozens, a family portrait will emerge. Page 11 is humility. Oumuamua reminded us that not every traveler grows a visible tail. Borisov showed that classic comets form elsewhere, too. 3. Atlas demonstrates how much we can learn when a visitor breathes steadily for months at a safe remove. None left souvenirs we could hold. All left clearer questions. That is progress in the quiet sciences. Fewer wild guesses, more well-posed puzzles. Page 12 is the future. Surveys are getting faster and deeper. The more we look, the more we will find some dim, some lively, a few perfectly placed. Engineers are sketching nimble interceptor spacecraft that could wait in deep space, fueled and ready to sprint when the next alert arrives. A compact camera, a tight spectrometer, a small dust counter, nothing fancy, just honest tools in the right place at the right time. We did not have that sprinter ready for this traveler. We might for the next. Page 13 is scale. The nucleus could be mountain-sized. The coma can swell larger than a planet, yet the gas is thinner than any vacuum on Earth. You could fly through the outer coma for hours and never hit a grain you could see. The brightness you notice through binoculars is sunlight scattered by countless tiny particles in a vast, airy cloud. That is why comets look like soft fingerprints in the sky. Page 14 is patience. Predictions come with wide sleeves because small changes in the crust can open or close vents and tilt the outcome. Models guide us. The sky decides. So we watch gently, we add notes to the curve, and we accept that some nights are quiet on purpose. Waiting is not empty. Waiting is where the details appear. Page 15 is the image to keep. The traveler has rounded the sun and is heading home to nowhere in particular. The coma thins like breath on cold glass. The tail becomes a faint river and then a rumor of one. The spin keeps its private tempo. The open curve carries on, unbothered, into the dark between stars. We close the notebook knowing a little more about how small worlds are made, how they wake, and how they move. The message has been read. The messenger goes on. Think of the galaxy as a library, and every interstellar visitor as a borrowed book that never gets checked back in. We cannot write in its margins. We cannot fold its pages. We can only read while it passes through the lamplight and remember what we learned. 3i Atlas is one of those books, concise, moving, and written in a script of dust and gas that sunlight makes legible for a season. Begin with how we turn light into meaning. A spectrum looks like a rainbow stretched thin, with delicate lines missing or glowing. Each dark notch is an absorption, each bright notch an emission, and together they spell the names of molecules. Water says, "I was built where ordinary ice survives." Carbon dioxide and carbon monoxide say, "I come from deeper cold." A hint of simple organics says, "Chemistry in the dark is patient." None of these signals are loud. They arrive as fine threads that careful instruments can tease apart, then weave into a plain story you can say out loud without math. Now consider the choreography of dust. When ice turns directly into gas, it lifts grains from the surface, and those grains inherit the spin of the nucleus and the push of sunlight. The result is a veil that never sits still. It peels, curls, and reshapes as the traveler turns and as the angle of light shifts. On long exposures, the dust tail looks like a smooth brushstroke. On shorter views, it reveals strands, the faint signatures of individual vents. Follow those strands night by night, and you can map where the surface breathes most strongly, even though the nucleus itself remains hidden. Even the simplest measurements quietly improve with time. A brightness curve is just numbers. How bright was the coma at this moment? Through this filter, from this place on Earth. Put enough points on that line and patterns appear. The rise quickens here, perhaps a vent opened. The slope flattens there, perhaps dust fell back and mantled an area. A soft, repeating ripple can hum with the spin of the nucleus as active patches take turns facing the Sunday. This is patient work, and that patience is as much an instrument as any mirror or detector. You might wonder why we keep returning to words like gentle, patient, and slow. It is not because the physics is dull. It is because the cosmos often speaks in quiet weather rather than thunder. A comet is a lesson in small forces accumulated, tiny taps from photons, faint pushes from jets, soft drifts of dust adding up to a glowing river you can see with your own eyes. The drama is cumulative. It rewards unhurried attention and becomes clearer the longer you listen. There is also comfort in scale. The nucleus may be a few mountains across. The coma may swell larger than a planet, yet the gas remains thinner than any vacuum we can make on Earth. You could hold your hand out inside the coma and wait a year without feeling a single grain touch your palm. The brightness is not density, it is the sum of countless specks spread through an enormous volume, each catching a bit of sunlight and sending it our way. That is why the view through binoculars feels honest, wide, soft, and complete. Perspective keeps reshaping the tail. From Earth, the dust tail may curl like a comma. From a space observatory, the ion tail can run razor straight from the coma's heart. From a different planet's angle, one hemisphere lights while the other rests, and the rhythm of the light curve shifts. The traveler does not change identity, we change vantage. Astronomy's quiet superpower is the way many angles fuse into a single, truer picture. What does all this tell us about ourselves? That planet building is not rare craftwork done in secret. Across the galaxy, disks of gas and dust have been forming and unforming worlds for billions of years. They shed leftovers, they trade fragments. Now and then, one of those fragments slides into our sky, and we borrow it with light. Oumuamua said the family is broader than we assumed. Borisov said, familiar ice lives in other kitchens. 3. Atlas says a visitor can stay bright and readable long enough for us to study the details calmly. A quiet thought follows. If fragments wander between stars, then our own system has likely contributed its share. Somewhere in the dark, a small object once warmed by our sun carries a faint record of our chemical weather. It will cross paths with no one we know. It will not send news back home. But its existence means the galaxy is threaded with the slow exchange of materials. We are not a closed room. We are a window in a house full of windows. People sometimes ask for the one big thing we learned from a visitor, as if understanding arrives like a headline. The truer answer is layered. We learn a little about chemistry, a little about spin, a little about how tails respond to solar storms, a little about dust sizes, and a little about how to listen better next time. Progress in this kind of science is not a loud yes or no. It is a clearer maybe, refined year by year until the maybe becomes a yes that fits comfortably. Imagine closing the cover on this borrowed book. The glow fades, the tail thins into a thread, and then into memory. The open curve carries the traveler out of our bright yard and back toward the quiet between stars. What remains is the record, images carefully dated, spectra aligned, brightness points stacked into a curve. Students not yet born will open that record, add it to another, and find the family resemblances we can only guess at tonight. As you rest, hold a simple picture. A dark seed turns in sunlight. Ice becomes breath. Dust drifts into a slow river. Nothing crashes. Nothing races. The sun writes in gentle strokes, and the traveler answers by shining. We read for a while, grateful for the loan, and then we let it go. Picture a simple timeline, like a ribbon on a table. On the left, discovery, a faint dot sliding between frames. In the middle, warming, the coma swells, the tail sharpens, the ion stream learns the sun's rhythm. On the right, farewell. The glow thins, the breath softens, the open curve carries on. 3 Atlas is a calm story told across that ribbon. We do not rush any piece. We read what the light gives and let the rest arrive when it is ready. Late October is the quiet pivot. The traveler is closest to the sun, most awake, yet hidden to many of our eyes because it sits in the glare. This is one of astronomy's gentle ironies. The show is brightest when curtains are drawn, so we wait, we prepare, and we listen with instruments that can handle the glare. Then, as the angle opens in the weeks that follow, The comet steps back into darker sky and the conversation resumes. Nothing was lost. The breath just continued off stage. What should you expect if you step outside after it returns to a safer angle? Not fireworks. A fingerprint, a soft patch with a brighter seed off-center, and a tail pointing away from the sun like a slow stream. You might not notice color. You might struggle at first and then suddenly see it. The way a shape appears when you stop staring and start breathing. Binoculars help because they welcome the whole glow at once. A small telescope will show more structure, but it is the wider, softer view that feels most honest. By then, the rhythm will have shifted. Early in the season, fragile ices like carbon dioxide often play a larger role. Later, as the surface warms deeper, water can take the lead. The light curve, those nightly dots on a graph, will tell the tale in a language anyone can understand, rising when vents open, flattening when dust blankets them, humming with a subtle beat if the spin brings active patches in and out of day. You do not need the equations. You only need to know that sunlight is patient, and ice responds in layers. Rumors will drift through the air as they always do. Could it break apart? Will it spark a meteor shower? Is it a risk? The quiet answers hold. Breakups are possible for some comets, but this one does not dive close to the sun, so stress is gentler. Meteor showers need a path that crosses Earth's orbit. This traveler's path does not. High speed is the signature of a guest, not the omen of a collision. The safest habit is the truest one. Look up, measure carefully, and let light, not headlines, set the mood. If you could shrink yourself and stand on the surface, protected as if in a dream, you would see darkness, quiet, and a slow sunrise that never brings air, only heat. The ground would be rough and dusty, with pits and ledges. On the sunlit side, faint jets would whisper from cracks, lifting grains smaller than smoke, each grain catching a piece of sunlight and wandering away. You would hear nothing. You would only feel a gentle nudge under your boots as gas slid past, a pressure so slight it would take hours to notice. This is the scale we are learning to appreciate, grand in size, delicate in touch. Perspective continues to teach. From Earth, the dust tail curves like a brushstroke. From space, the ion tail can run razor straight and show creases when the sun sneezes a storm. From another planet's vantage, a different hemisphere wakes, and the brightness pulse shifts. None of this is trickery. It is the same traveler, the same physics, viewed through several windows. The more windows we open, the truer the picture becomes. And quietly, in the background, a new habit is forming. We are learning to prepare ahead. We keep playbooks. Who will take spectra? Who will watch the light curve? Who will chase the tail's changes? We refine software that recognizes faint movers. We practice handing off observations across time zones so the record stays unbroken. We do this because interstellar guests announce themselves on their own schedule. If we are ready, we greet them with instruments instead of opinions. There is a deeper reason this matters. Interstellar visitors let us test how universal our recipes are. Do most small bodies start with similar layers? Do they wake in similar sequences? Do they carry the same balance of simple gases? With each traveler, we add a line to a growing chart. Oumuamua wrote, "Tails are not guaranteed." Borisov wrote, "Classic comets live elsewhere too." 3I Atlas writes, "Given time and calm, a visitor can be read in detail. None of these sentences contradicts the others. Together, they form a paragraph that points toward a shared grammar of small worlds. The human part is not a footnote, it is the backbone. Someone unlocks a small observatory in the cold and logs an hour of clean measurements. Someone stacks images on a laptop that has seen better days and finds a filament in the dust tail no one noticed last week. Someone maintains a database, checks units, adds a note so the next person does not repeat a mistake. These acts are not romantic. They are better than that. They are the craft of attention, quiet, repeatable, generous. When the visitor fades again and the archive closes, we will still be thinking ahead. What if the next guest is dimmer but closer? What if it arrives with even less warning? What if the chemical balance is stranger than we expect? Questions like these do not keep us awake with worry. They simply keep us awake with curiosity. They shape better plans, clear checklists, and cleaner code. They also teach a lesson that travels well beyond astronomy. Most puzzles yield to steady hands and shared time. Hold one more image for your pocket. Imagine the traveler far beyond Mars now. Its glow a faint echo of what it was, its tail a ghostly rumor stretching behind it. The sun is smaller, the warmth gentler, the breath almost gone, but the spin continues, and the open curve keeps its promise, carrying the object back into the deep, cool quiet between stars. Behind us, on Earth, a thin stack of data has become a memory we can open whenever we like. In front of us, the night is not empty. It is simply waiting for the next knock. When that knock comes, we will know what to do. We will open the dome, breathe, and listen. We will let light translate the visitor's story in its own slow voice. We will remember that speed does not mean danger, that distance can be a gift, and that patience is a kind of instrument. We will read, we will learn, and we will let go again. Think about how stories form around objects like this. A stranger appears in the sky, faint and slow, and people fill the silence with guesses. Some imagine omens, some imagine engines. The truth, almost always, is quieter and more beautiful. Sunlight, ice, dust, and time. 3I, Atlas, is not a warning and not a secret machine. It is a small natural thing that invites a skill we often forget: patient attention. Patient attention is a kind of telescope you can carry anywhere. It starts with noticing. Step outside before dawn in a dark place. At first, you may not see the visitor at all. Your eyes need time to adjust. 10 minutes in the quiet, and stars multiply. 15 minutes, and the Milky Way glows like a pale path. Then the comet appears as a soft patch near a familiar star, like breath on glass. It was there all along. You simply needed a slower heartbeat. A simple field guide helps. Face away from bright lights. Let your phone stay dark. Use binoculars with a steady grip, or brace your elbows on a fence rail. Sweep slowly. When you find the glow, do not chase it with high magnification. Linger. Notice how the tail points away from the invisible sun below the horizon. Notice the brighter seed at one edge, the hidden nucleus sending a slow breath into space. If thin clouds pass, wait. The comet will still be there, patient and unchanged. In cities, where the sky is washed with light, the view changes but does not vanish. A small telescope on a balcony can be enough. You can also learn the simple art of stacking a few short photographs into a deeper one later. It is not cheating. It is a way to let time help your eyes. Astronomers do the same at grand scales. Many short exposures carefully aligned reveal truths a single glance would miss. Quiet minutes become a clear picture. Behind every gentle image lies a scaffolding of teamwork. When a survey flags a moving dot, someone schedules time on a larger telescope before sunrise. Someone writes code to clean noisy measurements. Someone else checks the orbit again, not because they doubt a colleague, but because double-checking is how you show respect in science. The best campaigns look uneventful from the outside. Inside, they are full of small acts of generosity, clear notes in logs, careful file names, and patient replies. Interstellar visitors also teach humility. We cannot rewind the galaxy and watch which star flung this object away. We cannot see the dark side of the nucleus or count every vent. We cannot predict the exact hour a crust will crack, but we can hold uncertainties honestly. We can say what the light shows, what it suggests, and where our inferences must stop. That honesty is not weakness. It is the strength that lets us trust the pieces we do know and build from them without drama. One sturdy piece is the way sunlight writes on dust. Picture the pressure of light as a gentle breeze that never turns off. Tiny grains feel it most, so they race down the tail. Bigger grains lag, tracing the traveler's curve. If the sun's own weather shifts, if a wave of charged particles flows past the ion tail, straightens, kinks, or briefly breaks, and reforms farther downwind. Photographs taken on different nights become a flipbook of that slow space weather, page after patient page. Another sturdy piece is rhythm. A comet's light often rises and falls with its spin. The pattern can be subtle, just a small breathing of the glow as an active region turns into sunlight and then back into shadow. Thread that pattern through days and you can sketch the length of a day on a world you cannot see. Even for an interstellar visitor, this rhythm belongs to small worlds everywhere. Turn, warm, breathe, rest. It is a universal lullaby, written by heat and shade, and read with calm instruments. Why does any of this matter if you never see the comet yourself? Because attention spreads. A calm campaign teaches better habits. We build instruments that are simple to use and clear to calibrate. We share data in open archives with notes a stranger can understand years later. We teach students to trust light over headlines. These habits carry into weather forecasts, climate records, and medicine. Any field where small signals add up to large truths and patient measurement beats quick opinion. There is also a kindness you can feel at the eyepiece. Share the view with a friend or a child and the conversation slows without effort. You point, they squint, you whisper where to look. They find it, and there is a small, private gasp. Nothing exploded, nothing demanded fear. A dot of light offered a lesson in patience, and for a minute 2 people were quiet together. In busy lives, that is not a small gift. It is a reminder that wonder often arrives on tiptoe. Think of this visitor as a lesson in quiet returns. We follow it in, we watch it wake, and then we keep it company as it glides back out. Nothing sudden has to happen for a story to be complete. A glow can be enough. A slow tail can be enough. There is comfort in knowing how small forces add up. Sunlight is a featherweight push on a dust grain, but trillions of taps shape a tail. Gas slides from shaded cracks and becomes breath around a dark core, and that breath turns starlight into meaning. You can hold that picture without equations. The comet is not a riddle. It is a long exhale in cold air. We read the exhale and learn about a place that will never see our sky again. For a human scale, remember how far a calm habit can carry you. A person who steps outside for 10 quiet minutes a few mornings in a row will see more than someone who chases a single perfect night. Patience beats luck. The same is true for every instrument pointed at 3i Atlas. The best records are not the loud ones, they are the steady ones, the series that do not miss a beat even when nothing dramatic happens. Later, when answers are drawn, those calm lines keep the rest honest. The traveler also ties us to people who watched the sky before us. Long ago, comets were warnings in some stories, blessings in others, and mysteries in all. We keep the mystery, but we trade fear for attention. Where our grandparents might have guessed, we measure. Where a headline might rush, we pause. The sky has never demanded speed from us. It has asked for care. That is why a faint patch in the morning can feel like a teaching, even if you only glimpse it once. Keep looking and you notice something else. The comet does not own the sky it occupies. It shares that space with planets that creep, with satellites that blink, with faint air glow that makes the horizon breathe. It is easy to think of the visitor as a lone actor on a stage, but the stage is alive. When a gust from the sun creases the ion tail, the planets feel that weather too. When the dust tail curves, it bends through the same light that opens the day for you. We are part of this same slow weather. Scale can be gentle rather than crushing. The Coma can grow larger than a planet and still be thinner than any vacuum we make. The nucleus can be a mountain and still hide inside a glow softer than a candle. The important part is not feeling tiny. It is feeling placed. You are in the same system with the comet and the star that wakes it. The same light warms your window and traces those grains, and that is a very old connection wrapped in a new story. As the season turns, the traveler keeps its rhythm. Event lights, event rests. A day on the nucleus passes in hours or a little more than a day. depending on its spin. The brightness curve hums with that tempo even as the overall glow fades. A quiet curve is not empty, it is the heart rate of a small world. To hear it is to accept that not all knowledge arrives with a cymbal crash. People often ask for a takeaway, a single sentence to pin to the fridge. It can be simple. Interstellar means unbound. High speed means freedom, not danger. Tails point away from the Sunday. Dust curves slowly, ions obey the solar wind. Chemistry carries memory of a birthplace in deep cold. Patience is an instrument. Those lines are enough to share with anyone who asks what you were doing in the yard before sunrise. On paper, this object is a file full of numbers and images. In memory, it can become a time you made room for wonder. Maybe you stood with a friend and traded binoculars back and forth. Maybe you failed to see it the first night and laughed, then found it the second night and went quiet. All of that counts. Science is not only about discovery, it is also about the care we learn to take with what is real. Imagine the farewell. The tail is a brushstroke that grows thinner each morning. The coma is a breath that fades like frost from a window. The nucleus keeps turning, private and steady. The open curve leads out, and nothing in the night marks the path once the glow is gone. That absence is not loss, it is the shape of the story. The visitor was never ours to keep. Our part was to notice, to read, and to let it go without drama. Keep one last practice. When you step outside, look for the faintest thing you can see. The point of the exercise is not the comet alone, it is your attention. The sky is generous when you meet it halfway. Stars multiply when you give them a minute. Planets announce themselves when you learn their slow pace. And sometimes a soft comma of light will appear where last week there was only dark. You will know what it island, you will know what it means, and you will know how to listen as it fades. That is the quiet gift of 3i Atlas. It is not a warning, and not a spectacle that demands applause. It is a visitor that teaches patience by being patient, that rewards care with clarity, and that leaves us with a better ear for small truths. We will see others, and we will be ready. Until then, the sky is still there, the light is still kind, and the book of quiet things is still open. Before we close this journey, hold one last, simple picture. A small, dark seed is gliding through sunlight. It does not belong to our Sunday, it will not stay. It came from far away, woke gently as warmth reached its crust, exhaled a thin, glowing breath, and kept moving. That is 3i Atlas in plain words. A visiting note slipped under our door and read by the light itself. What did the note say? Motion. Its path is open, not closed. Gravity bends the curve but never ties a knot. Far from the sun, the traveler keeps a leftover, cruising speed. Near the sun, it borrows extra and pays it back on the way out. That tells us it was made elsewhere and set free long ago. Light. The nucleus hides inside a soft coma, a thin atmosphere made from its own ice. Sunlight turns ice into gas. Gas lifts dust into the glow. The dust tail curves like a brushstroke. The ion tail points almost straight away from the sun and creases when a gust of solar wind passes. Gentle rules everywhere. Dust follows light's push. Ions follow the wind. Rhythm. The surface is cracked and lumpy. As the nucleus turns, active patches face the sun and then rest. The brightness rises and falls like a slow heartbeat. Sometimes a crust patch breaks, fresh ice wakes, and the glow jumps. Not danger windows into older layers. Chemistry. The gases carry an accent. Water means ordinary ice. Carbon dioxide and carbon monoxide hint at deep cold. Simple organics ride along in tiny amounts. The balance is a clue, not a headline. It says that planet building far from a young star can lay down layers that wake in order when warmed. We are reading someone else's freezer, slice by slice. Perspective. The same comet looks different from different balconies. From Earth we saw a soft cloud. From space, the ion ribbon stretched fine and straight. From another world, the angle would shift and the rhythm would change. The comet is steady. Our view is not. Perspective is an instrument. Safety. High speed does not mean harm. Interstellar means unbound, not inbound. The traveler stayed far from Earth. No meteor showers, no threats. Only time to measure without panic and let small truths add up. People, a survey flagged a mover. Observers answered. Big mirrors and small scopes shared the load. Coders cleaned data, students checked sums. Clear notes, careful files, open archives. Science, at its best, generous, steady, patient. Meaning, 3 interstellar visitors in less than a decade changed our sense of home. Oumuamua said not every traveler shows a tale. Borisov said classic comets are common. 3i Atlas showed how much we can learn when a guest stays readable for months. Together they say the galaxy trades small things all the time. We are part of that slow exchange. You may hear people call 3i Atlas the new Oumuamua because late October put it in the news and in our imaginations. The comparison is a doorway, not a verdict. This one wore a tail and a clear halo. It behaved like a natural comet waking up calm, textbook, generous with clues. The name ties it to a story we remember. The light shows how this chapter is different. If you step outside on a late October morning, expect a fingerprint, not fireworks. Find a dark place, let your eyes adjust, and sweep slowly with binoculars. You may see a soft patch with a thin tail leaning away from the hidden Sunday. That quiet view is enough. What comes next for the traveler is simple. The curve carries outward, the coma thins as heat fades, the tail becomes a ghost river, and then a rumor. The nucleus cools and sleeps again. Nothing explodes. Nothing is lost. The message was delivered. The messenger goes on. What comes next for us is also simple. Keep the record, keep improving our eyes, and keep a small plan ready for the day we can launch a sprinter to meet the next guest. There is modest wisdom in this kind of story. Big truths rarely arrive with thunder. Most come as soft patterns that survive checking. Sunlight is steady, ice responds, dust remembers the pushes it felt, gas follows invisible fields. Over time, those notes merge into music. If the cosmos ever feels too large to know, remember that knowing often begins as a quiet dot that shifts a little between frames. So carry this closing image into sleep. A dark seed turns in faint sunlight far beyond Mars. From its sunlit edge, slow jets rise and fade. A thin river of dust drifts into black. The ion ribbon points from the star like a taut silk thread. No engines, no omen, only a fragment from another system, breathing for a season near ours. We read that breath in simple light and feel more at home in a big place. When people ask what 3i-ATLAS was, you can say this: a visitor from another star that woke gently as it passed our Sunday. It grew a halo and 2 tails. It posed no danger. It let us test our instruments, our teamwork, and our patience. It taught us that the universe often speaks in quiet weather, and it left us ready to listen for the next knock at the door of our sky. If you like dates, keep the arc. Discovery mid-year, warmth and glare in late October, a calmer return to view in the weeks after. Or forget the calendar and keep the feeling: starlight turning ice to breath, a community paying attention, and the promise that we will meet others. The book of quiet things stays open, the night stays kind. The road between the stars stays busy, even when we cannot see it, and the light keeps writing, line by gentle line, across the dark. Sleep well. The traveler is on its way, and we are too curious, careful, and ready for the next story the sky decides to tell.